We are literally standing right at the edge of a biological revolution. For centuries, right, the idea of drastically extending human life, it belonged completely to mythology or sci-fi. But today, that pursuit of extreme human longevity has stepped out of pure fantasy and firmly into the bright, undeniable light of hard science. We're going to unpack the cutting-edge research that is fundamentally shifting how we understand human biology, how we age, and what our ultimate physical limits really are. The smartest minds and honestly the deepest pockets in biotechnology are all converging on this single, audacious goal: rewriting the rules of human decay. This isn't just about, tweaking your diet or getting on a treadmill more often. No, it's about fundamentally hacking the source code of human biology to extend our runway way, way beyond what we ever thought possible.
So think about this for a second. What if the human body could actually reach 150 years old? I mean, it's a staggering thought, right? While it sounds totally like a futuristic novel, billion-dollar research institutes like Altos Labs and top researchers at places from Harvard to Stanford are already actively working to make this our reality. They're looking under the hood of the human machine, analyzing how our cells degrade, and they're daring to ask, why does our biology have to just stop at 80 or 90? Massive amounts of capital are flooding into this longevity sector, and it's all driven by this new consensus among leading geneticists that aging might not be some inescapable law of nature. Instead, it's starting to look like an engineering problem. A complex one for sure, but one that's waiting to be solved. We're moving away from this passive acceptance of getting old, and we're stepping into a world of active intervention, treating the aging process itself as something we can actually change, not just an inevitable fate. Now, to truly wrap our heads around the magnitude of where we're headed, we gotta look at the absolute ceiling of where humanity stands right now. 122. That is the highest verified age a human being has ever lived to on record. That title belongs to a French woman named Jeanne Calment, who passed away back in 1997. Get this, she famously met Vincent van Gogh, she rode a bicycle until she was 100 years old, and she credited her crazy longevity to olive oil, port wine, and chocolate, which honestly sounds like a pretty great recipe. It's an amazing, almost unbelievable milestone. But for decades, the scientific community looked at Jeanne's record as an absolute hard stop, like the absolute maximum capacity of the human machine, a complete genetic lottery ticket that the rest of us couldn't even dream of hitting. But, and this is where it gets exciting, the latest science is suggesting that 122 might not actually be a permanent ceiling. It might just be a temporary baseline.
Researchers are aggressively pushing back on that old assumption, mainly because they've realized this one fundamental truth: aging is not just the passage of time. For all of human history, we've looked at aging completely passively. The years tick by, and our bodies simply wear out, kind of like a car engine just succumbing to normal wear and tear. But modern cellular biology, it is completely tearing down that framework. The field is totally shifting from viewing aging as this irreversible breakdown to recognizing it as a highly complex biological program. And here's the kicker. It's a program that can actually be updated, paused, or maybe even rebooted. Time itself isn't the enemy causing the damage. It's the underlying biological pathways that are failing over time. So when we stop looking at aging as just a literal calendar on the wall, it suddenly opens up this massive, wild world of therapeutic possibilities. And that brings us to a really crucial distinction that totally redefines everything we thought we knew about getting older. There is a profound difference between your calendar age and your biological age. Your calendar age is literally just keeping time. It's how many times you physically orbited the sun. There is absolutely nothing you or I can do to change that number. But your biological age, that is a dynamic physical condition happening right now, deep inside your cells. It's driven by really specific mechanisms, things like epigenetic alterations, telomere attrition, and mitochondrial dysfunction. I know, big words, but basically aging at its core is cellular. It's a series of microscopic pathways that are breaking down. And this distinction is the absolute bedrock of modern longevity research. Because we can't stop chronological time from passing, but a biological physical process, that is something we can intervene in, modify, and potentially even master. Because we now know aging is a physical mechanism and not just some unstoppable cosmic clock, scientists are currently studying ways to actively slam the brakes on the biological process itself. They aren't just trying to make us, a little more comfortable as we decline. No, they're attempting to literally manipulate the underlying mechanics of biological degradation. And we are already seeing some unprecedented breakthroughs here. For instance, researchers have actually used epigenetic reprogramming to reverse age-related vision loss in mice. They effectively turned back the biological clock of specific eye cells to a youthful state, all without altering what those cells fundamentally were.
Tangible success stories like this are validating this incredible hypothesis. Biological aging isn't a one-way street. It's actually a flexible, incredibly complex process that responds to targeted biological interventions.
So how exactly are they doing this? Well, researchers are deploying a really advanced multi-pronged assault on cellular degradation. Think of it as a modern scientific toolkit that represents the absolute bleeding edge of biotechnology. First up, we've got gene therapy. This is being used to literally alter our genetic instructions, aiming to boost the genes that give us longevity and resilience. Then there's cellular reprogramming, specifically using what are called Yamanaka factors. This is a mind-blowing process where they basically wash the age right out of a cell, forcing it to revert to a youthful, blank slate state. On top of that, regenerative medicine is stepping in to engineer entire tissues and organs to replace the ones that fail. And finally, researchers are developing senolytics. These are specialized drugs designed to hunt down and clear out senescent cells. Basically, they're zombie cells. They're aging cells that refuse to die, and instead they just sit there and secrete toxic inflammatory stuff that speeds up the decay of all the healthy tissue around them.
The whole philosophy driving this futuristic toolkit can really be distilled into one monumental shift in how we think about medicine: repairing damaged cells instead of simply treating the diseases caused by aging. If you think about it, historically, global healthcare has been a totally reactive enterprise, right? We wait until cellular damage builds up into a catastrophic failure, like heart disease, Alzheimer's, or arthritis, and then doctors scramble to just manage those symptoms. It is incredibly expensive, and frankly, it's a pretty inefficient way to practice medicine. But the longevity frontier, it completely flips the script. It makes healthcare highly proactive. By going in and actually repairing those damaged cells and molecular pathways before they ever get the chance to turn into a disease, we're targeting the root cause of physical decline. The societal and economic impacts of shifting from just managing symptoms to actually doing proactive cellular maintenance, it would be absolutely staggering.
In practice, this completely reimagines your entire journey as a patient. Just imagine walking into a clinic, say 10 or 20 years from now. Step 1, your doctor isn't going to just run through a basic physical checklist. Instead, they'll detect your biological aging early using hyper-precise epigenetic clocks and DNA tests that show exactly how fast your internal systems are wearing down. Step 2, way before you ever actually feel sick, they will proactively intervene to repair those damaged tissues. They might use those senolytics we talked about to clear out the zombie cells, or use gene therapies to boost your cellular resilience. And the ultimate result? Step 3, keeping the human body healthier at a molecular level for a significantly longer period of time. You wouldn't be going to the doctor because you caught a disease. You'd be going to the clinic for routine, preventative maintenance on your biological hardware, kind of like getting a tune-up for your car.
Now, as thrilling as all these breakthroughs are, we do have to take a step back and acknowledge a massive looming unknown. We still have absolutely no idea what the true biological limit of the human lifespan actually is. The human body is this absolute masterpiece of complexity. We're talking 30 trillion cells communicating in ways we still barely even comprehend. So trying to perfectly tune it, it's kind of like trying to rebuild a jet engine while it's actively flying at 30,000 feet. Despite all of our crazy advancements in cellular reprogramming, science still hasn't definitively figured out if we can bypass hardwired biological constraints, like the Hayflick limit, for example, which is this concept that normal human cells can only divide a certain number of times before they just stop. So what is the ultimate ceiling? Is it 130, 150? Or with the right cellular tweaks, is there no strict biological limit at all? That mystery right there is basically the holy grail of modern biology. Ultimately, the driving force behind this entire scientific frontier boils down to one essential distinction: lifespan versus health span. Because let's be real, the objective of longevity science is not just lifespan. Adding arbitrary years to the end of your life, just putting a higher number on a birthday cake while you languish in a hospital bed, that's a failure. The real target here is health span. It's about maximizing the number of years we spend healthy, robust, and completely independent. In the scientific community, they call this morbidity compression. Basically, it means taking that period of sickness and decline at the end of life and squeezing it down into the tiniest possible window. Nobody wants to live to be 150 if the last 50 of those years are spent in frailty, right? The fundamental mission of all this research is to inject vibrant, uncompromised quality into every single extra year we manage to unlock. So if the science actually delivers on this incredible promise, if biotechnology successfully expands your health span right alongside your lifespan, we're suddenly faced with the ultimate philosophical dilemma. Would you actually want to live to 150? It's a profound thought experiment, and it challenges the very foundation of how we structure human existence. Think about it. If you knew for a fact you had a century and a half of vital, healthy life, how would that change the trajectory of your career? How would it reshape your marriages, your relationships, your entire perspective on urgency and purpose? If aging becomes just a manageable condition rather than this inescapable countdown, the question isn't just how long we can live anymore. The real question is, who will we choose to become with all that extra time?